Okay, we begin with L'Hopital's rule. So this is how you say it, L'Hopital's rule. So L'Hopital's rule is used when taking a limit. So when we're taking a limit and we get 0 over 0 or infinity over infinity, we know that that means more work, but now we have a new way to do the more work. We don't have enough math knowledge for me to be able to prove it to you, but what we do is we take the derivative of the numerator and the denominator, but we do not do quotient rule. But it first off has to be one of these two forms in order for us to do that. So let's look at this first example. So here I have a limit. If I plug in x equals 0, I get 1 minus 1, that's 0, over x equals 0, that's 0. So it is of the correct form. It is 0 over 0. So I take the derivative of this. So derivative of e to the 3x is 3 times e to the 3x. Derivative of negative 1 is 0. The derivative of x is 1. Now I try plugging in x equals 0 again. I do, and I get e to the 0, which is 1, so I end up getting 3. So this is using L'Hopital's rule. So let's try this one. So the limit can go to anything, could be going to 0, could be going to infinity, could be going to different numbers. So I've got this one going to 0, so every one changes. So I always have to check first. So if I plug in infinity, I get ln of infinity from here, that's infinity. Another ln of infinity, that's infinity, over infinity. Okay, so I have infinity over infinity. So now it's time to do L'Hopital's rule. So I take the derivative of this ln first. So I have 1 over ln of x. Then I take the derivative of this ln, and I get 1 over x. That's all in the numerator. Then I take the derivative of this x, and I get 1. So now, I know that ln of infinity is infinity. And I know that this is going to give me 1 over infinity and a 1 over infinity. So these are all things that I'm thinking. 1 over infinity gives me times 1 over infinity. That gives me 1 over infinity. That's 0. So again, we don't write all those steps. We just think it and we say, okay, I have a 0 as an answer. All right, let's plug x equals 0 in. So I get 0 and 0, that's a 0. 0 and 0, that's a 0. Okay, let's take the derivative. Derivative of x is 1. Derivative of sine is cosine. Derivative of x is 1. Derivative of tangent is secant squared. Now plug in x equals 0. So cosine of 0 you know is 1. So I get 1 minus 1, that's 0. But plug in x equals 0 into secant squared, that's 1. 1 minus 1, that's 0. I get to do L'Hopital's again. All right, derivative of 1 is 0. Derivative of negative cosine is positive sine. Derivative of 1 is 0. Now to take the derivative of secant squared, that is chain rule. So I carry the negative along, bring the 2 down, secant of x to the 1 power, then I multiply by the derivative of secant, which is secant tangent. All right, so if I plug in x equals 0, I get 0. Secant of 0 is 1, and a tangent is 0. So I end up getting 0 over 0 again. All right, so if you don't simplify it, this would just be horrible, wouldn't it? Be a triple product rule down here. So this is one of them that I want to make sure that you're investing time simplifying. So let's change it all to sines and cosines. Change the secants to 1 over cosine, tangents to sine over cosine. So multiplying by the reciprocal and simplifying, oh my goodness, look at that. Turns out to just be cosine cubed, and I can plug in x equals 0. Cosine of 0 is 1, so I get a negative 1/2. And I got this negative 1/2 by pulling this negative 2 on the outside, right? That was in the denominator. All right, going to infinity. So if I plug in infinity, ln of infinity is infinity, and I have infinity on the denominator, so I do have infinity over infinity. So it is L'Hopital ready. So to take the derivative, I'm doing chain rule here, right? So bring this 2 down, carry ln of x along to the 1 power, and then multiply by the derivative of ln of x, which is 1 over x. Derivative of x is just 1. So let's spend some time simplifying this. So this x comes down to the denominator. So now I'm going to plug in infinity. So I get ln of infinity, which is infinity over infinity. So I get to do L'Hopital's again. So in the numerator, I get 1 over x. In the denominator, I get 1. Now plug in infinity. So I get 2 over infinity, which is 0. All right. Here I've got x to the a and x to the b. So if I'm plugging in 1 to an a and b are just constants. So 1 to a number is 1. So I'm going to get 0. 1 to a number b is going to be 1. So I'll get 0 over 0. So this one here, taking the derivative, so it's like saying x cubed and x to the 4th. I take the derivative, bring the number down, subtract 1 from it, bring the number down, subtract 1 from it. Now plug in x equal 1, and these 1 to the a minus 1 and b 1 to the b minus 1, those just go away, so I just get a over b. Last one here. So now I have 3 to the x and 4 to the x. So 3 to the 0 gives me 1, 4 to the 0 gives me 1, so that gives me a 0 over a 0. So it is L'Hopital ready. So you know and you remember the derivative of 3 to the x is 3 to the x times ln of 3. Derivative of 4 to the x is 4 to the x times ln of 4. So now when I plug in 0, I just get 3 to the 0, which is 1, and 4 to the 0, which is 1, so ln of 3 minus ln of 4.